So I take him in this other room, and we're in the radio station. There's windows everywhere, so people can see. There's people outside watching. And he's sitting there. I said, okay, close your eyes. And so he closes his eyes. He's like, am I doing everything okay? I'm like, your eyes are closed. That's all you have to do. Okay. So he sits back down. So I said, okay. Then I start doing my script the one that I commonly use to induce someone into a trance. And basically it involves them opening and closing their eyes quite a few times. And so about, I don't know, halfway through this induction, he like looks at me, he's like, it's not working. And I'm like, it's okay, it's fine to think that, just play along. And he's wiggling. I mean, most people are like, and drooling, and not really drooling, but you know, they're just like really relaxed. And he's just like still shaking. So I went through the whole thing. I told him that donuts from now on were going to taste like, I don't even remember what I told him, something nasty. So every time he ate a donut, it would taste like that. And then it was it. Like, okay, go. Now he is definitely on the extreme end of the least suggestible person I've ever worked with in my entire life. So he gets back on the radio, he thanks me, he's very nice. As soon as I get out in the car, I flip the radio on, and there he is, bashing me to no end. Oh, it was ridiculous, I knew exactly what was going on, didn't work, you know, what a joke. I mean, oh, it was horrible. I had to turn it off, because here I am. Now granted, I don't do this for a living, but still, it's an integral part of when I work with a lot of my athletes to help them overcome different things. So I was just like, oh my God. So finally, I turned it off, I drive away. Like 3 days later, my phone rings, and it's one of my friends. He's like, you gotta turn the radio on, they're talking about you again. It turns out he hadn't eaten a single donut since then, and all of a sudden he's all excited about it. So even though, you know, it's the lower end, you can still have some sort of progress. So simple things like that. Now granted, he's not gonna have, you know, stitches put in without any sort of anesthesia because he's not suggestible enough. But simple things like, you know, getting people to stop eating donuts. I actually worked with someone that had a popcorn addiction once, couldn't stop eating popcorn out of all things. Just go figure. But a lot of athletes have weird things like that. Like I worked with a golfer, wasn't on the professional tour, but got paid as a golfer. And you know, like a club assistant pro. When he competed, when he would go up onto the tee, he was scared to death of people watching him. So, you know, did stuff like that. And it doesn't require that great of a depth for that to happen. So this would be a good example of something being positively skewed. These people up here, these are the people that go up on stage. They're great for stage shows. They're also the people that can do wonderful things with. My daughter, for example, has never had a shot of Novocaine in her life in her mouth. All of her cavities, all of her teeth have been pulled, everything with no anesthesia because I've hypnotized her for it. She's definitely way up here. So no anesthesia whatsoever. All right, so here are the formulas for skewness. Now remember, having said this already, I'm just going to repeat myself. The chances of us dealing with a population in the real world are very slim. There are special times that will be the case, but in general, we're going to be dealing with the sample. For me, in this class, and any of the classes I teach, you are only going to be doing the sample skewness. You will not be calculating the population skewness for me, ever. When I wrote this book, I have a Mac, my version of Excel only could do this one at the time. It couldn't even do that one. So we're just doing the sample because that's the typical one that's calculated. So let's look at it. So remember, the standard deviation or the variance was the sum of x minus x bar squared. So now we need the sum of x minus x bar cubed. All right. So if we already have done the math for the standard deviation or the variance, we're already going to have x minus x bar squared. So we just multiply it by x minus x bar again. And then we create a new column and we add it up. N is the number of pieces of data I have. So n minus 1 is, so if n is 10, n minus 1 would be 9, n minus 2 would be 8. And s cubed. So s is our standard deviation. So once you have your standard deviation, you just cube it. Now, for those of you who haven't been in a math class in forever, what does that mean? 2 cubed is 2 times 2 times 2. So 2 times 2 is 4, times 2 is 8. So 2 cubed is 8. You just multiply it by itself 3 times. So whatever s is, you multiply it by itself, and then by itself again, and you get s cubed. All right, instead of going through the procedure, let's look at an actual example, because that way we can see in the table how it's laid out. Now remember, this is definitely an example of a more challenging example of skewness, because most of the time we're probably going to be dealing with whole numbers in this class. So in that case, you're not going to have such large numbers when you're done. So this is a little bit of an extreme example. So we have our x values. Remember, we have our x bar from the first class, which is the mean. So we take our x value, subtract the mean, and we get that. We already did this 2 classes ago when we calculated the variance and the standard deviation. Also, back in that class, we found out that the standard deviation is 0.0669. So we already know that. So to get our s cubed, we're just going to multiply that by itself and by itself again. All right, so now that we know x minus x bar, we need to cube it. So negative 0.115 times negative 0.115 times negative 0.115 is negative 0.0015209. Now, again, you do not have to carry these numbers this far. 2 digits past the original data is plenty. So we have 2 here, so you could have carried it just out to the 4. The problem is, if you do that, look at these here. These are basically all going to be zeros, right? Which is not going to be very helpful. So when you're calculating this, I would suggest carrying the numbers out, assuming there's actually significant digits there, out as far as possible on your calculator. That way you're not going to be making so many rounding mistakes. You can always do this all the way out as far as you can, and at the end you can round it if you want to. Because look at this. I mean, that's 0.007. That might be different if I completely eliminated all these numbers there. Right? Okay. So we cube all these, write them down in a column. We add all these up. And this is what we get. This is the sum of x minus x bar cubed. Now we're going to plug that into our formula. So our formula says we need the sum of x minus x bar cubed, which is that, n, which is 10, n minus 1, 10 minus 1 is 9, 10 minus 2 is 8, times s cubed. So we took our standard deviation, multiplied it by our standard deviation, multiplied it by our standard deviation, and we got this thing. Plug all that in, and we get negative 0.3343. That means this distribution is negatively skewed. So the mean should be less than the median, which if you look back in your notes, it is. And it gives us an idea of what the picture of the data looks like. All right, so yes, this is somewhat challenging. I will tell you this. If you can handle this math, this is the most difficult math you're going to have this entire semester. Now, there's going to be other things later on this semester that are going to be equal to this, but there's nothing more difficult than this. So if you're seeing this at the beginning of the semester and you're panicking, saying, oh my God, what am I going to do? I'm never going to be able to do the harder stuff. This is it. There's really nothing more mathematically challenging this semester other than this. Okay, so once again, at the end, we have 4 sets for samples. Try it on the easy one first. Do the calculations. See if you get the right answer. If you do, you're fine. If you don't, then start practicing on these. You're going to get pretty large numbers for this set, and you're going to get pretty large numbers for this set also. So, but do it and see what you get. See if it works out.